Hello everyone, welcome to our next talk, Bad Actors versus Our Community, Detecting Software Supply Chain Attacks on the Python Ecosystem. Please welcome Ashish Bijlani.
Thank you and welcome. Thank you for attending my talk. This is on supply chain attacks. So let's get started. I'm Ashish. I hold a PhD from Georgia Tech in cybersecurity, and this is where you can reach me. I work at Oscillate. I'm a research scientist, and we are developing tools to detect software supply chain attacks. So open source software is the de facto standard way of building digital apps and services today. Modern open source software is distributed as packages on package managers. Examples of package managers include NPM and PyPi. For example, PyPi hosts over 300,000 Python packages, and they receive millions of daily downloads. So anybody can publish their package on these package managers. They make it super easy. They ship a command line tool that you can use to publish your package. Frictionless single command publishing. However, there's limited security vetting. What does that mean? That means the software that we use on our server, desktops, laptops, other devices is written by unknown volunteers, which we blindly trust. And bad actors exploit exactly this trust. And this is evident from several past incidents. According to a recent study, the supply chain attacks have tripled in 2021 alone. And these attacks have been carried out on all ecosystems, NPM, PyPi, no ecosystem has been spared. So what are these supply chain attacks? So attackers target less secure packages or the weak links in your supply chain, and they inject malware in the supply chain by publishing malicious packages. Unlike vulnerabilities, malware is intentionally harmful. It's not an accidental programming bug in a benign code. It is purposefully harmful. For example, a backdoor that is installed immediately upon package installation, and that steals your SSH keys or Bitcoin wallet addresses. Such attacks pose direct and dangerous threats because the same malware can be adopted by millions of devices. Right? And yeah, like I said, it has a wide blast radius. So what are these techniques? So that attackers use to publish malware. So one such technique is typosquatting. So under typosquatting, attackers publish packages with similar names to existing popular packages and exploit inexperience or carelessness of developers to supply malware. For example, a name typo during a package installation can end up in malware. In the slide here, we have shown a couple of examples. For example, Colorama impersonates a popular package, Colorama. And if you make a typo, then you can end up installing malware on your machine. So let's take a case study, and let's dive deeper into what these malicious packages are. So let's take MIT mproxy 2 as an example. It personates a popular package called MIT mproxy. As you can see, the project description is exactly the same, and some of the stats are the same as the original package. So an inexperienced developer may mistake this package as an upgraded version of MIT mproxy and download it. But if you look at the code, what this package does is it removes some of the safeguards. So anyone on the same network can execute code on your machine with a single HTTP request. Social engineering is another technique that attackers use to dupe maintainers and inject malware. NPM package event stream is a good example. Here, the attacker first gained trust by posing as a benign contributor and contributing useful features. And later, he asked to maintain the package event stream. And after gaining the contributor privileges, the attacker published malicious code that searched for Bitcoin addresses. The developer of the package in maintenance mode actually trusted because the attacker was supposedly benign, and he contributed popular or good features. So this package is a good example because it receives millions of weekly downloads. Another technique that attackers use is dependency confusion. So enterprises, they use internal mirrors of package managers. For example, there will be an internal mirror of PyPi that is synced with the external package managers as needed. And the technique exploits the default behavior of this artifactory to always use the higher version of the package that's available externally. Right? So what can attacker do? An attacker can go through manifest file available publicly, find out what packages are being used, for example, at Microsoft or other enterprise, and they can publish higher malicious versions of the same package. And as a result, the artifactory will now install the external malicious package, and the malware will be in their apps and services. There have also been cases of account hijacking to inject malware in open source packages. A popular example is UA Parser JS. It's a JavaScript package with 8 million weekly downloads. The package is actually used in apps and websites to discover the type of device or browser the person is using from user agent data. The attacker here hijacked the account and published malicious version of this popular package. Let's look at another case study. So this is a Python package that we found, and we reported to the PyPi admins in January. We found that this package downloads a malicious payload from this URL and executes the code by spawning subprocesses. And we saw that the email address on this package was invalid, and that's why we looked into this, and also we analyzed APIs. So I'll get to that briefly. So how do we defend against such attacks? Well, security is a shared responsibility, and as a community, we must all do our parts. For example, maintainers and package managers can adopt two-factor authentication to protect against account hijacking. Package name scoping can also reduce risks of Typosquatting attacks. However, these measures fall short because, as we have seen with the recent protestware, a disgruntled developer can sabotage their own package and inject malware. So developers must use a zero trust approach. They must thoroughly vet code and behavior of every package, every dependency they use. Easier said than done. This is because manual vetting is infeasible, as packages may have hundreds of dependencies, include direct and transitive. This slide shows dependency of PyTorch, a popular Python package. By the way, this graph only shows transitive dependencies that are at a distance of 2 or less from PyTorch. So as seen from this graph, PyTorch includes several dependencies, and manually analyzing each one would be tedious and error-prone. We can use tools. However, existing tools only report known CVEs, publicly known CVEs in NVD or other public database. For example, Sneak Advisor reports no vulnerability with glaringly malicious packages here. So this is an example package, maybe uploaded by a security researcher that says, this is an example package to demonstrate a malicious code inside. And Sneak Advisor reports no security risks. If you delve deeper, you'll see that this package generates and executes malicious code at runtime that reads your SSH keys. How about stats? Can we rely on stats like GitHub downloads or stars or forks? Well, such stats are attacker controlled. Attacker bot can easily manipulate downloads or forks. And more importantly, there's no verification of package provenance, source provenance. So it may point to a popular package on GitHub. For example, this slide shows starjacking, where an attacker can easily trick users by pointing to a popular source on GitHub. So this points to a sample Python project, and it has over 4,000 stars and over 1,500 forks. no verification, like I said, no verification is done for the source repo by package managers. Therefore, blindly trusting such vanity stats would be naive. So Packj is our solution. We are developing an automated tool to vet packages that you adopt. So we take a zero trust approach. We vet every API. We vet multiple attributes of packages, multiple risky code as well as metadata attributes. And we provide actionable security insights. For example, we test for weak links by checking is the package old or abandoned. Abandoned packages or old packages may not receive security fixes, so they must be avoided. Does the package read or send your data over the network? As we have seen from the example malware, malicious packages, usually they read files, they try to steal your sensitive data, which will be in file, and they'll send this to a remote server. So a package that's reading and sending data over a remote server is fishy. It must be thoroughly checked. And finally, is the source repo publicly available? Because if it is available, we can go and check the source code, and be sure that the package indeed contains the code that is displayed on public source repo. So Packj is a command line tool, and you can customize it to your threat model. For example, if you think that two-factor authentication may not be risky for you, if you perceive as lack of two-factor authentication is not risky, you can turn off that alert and minimize noise. So how does it work? We use static analysis. Specifically, we look at APIs that are being used by packages. These APIs are provided by the language ecosystem or the operating system, and malware has to go through these APIs if they want to execute any sensitive functionality or get access to any sensitive data. For example, if they want to read files, they'll have to call open read write file system APIs. If they want to send data, they need to call these socket APIs, network APIs. And if they want to generate code at runtime, downloading malicious package or malicious payload at runtime and execute them, they have to use exec or eval or fork. So we track these APIs, and depending on your threat model, we provide alerts to you. We also look at metadata analysis. For example, we look at maintainer email, is it valid or not? Invalid email suggests no factor authentication. We check for abandoned packages because they don't receive security fixes. We check for public source repo for code verification. And we do some Typosquatting detection based on name similarity. So time for some action. Let me all right. Let me demo the tool to you. Okay. Cool. So this is the source code. It's hosted on GitHub, and we'll get to that. Let's try to vet a package here. Does anybody have a popular package that they want to vet?
Twisted.
What's that?
Twisted.
Twisted. Twisted, is that correct? All right, some errors. Work in progress. We are fixing it. But it did analyze the version. It found version 2240. It checked the author. It checked the email. It checked the README. There's sufficient README. The version is only 19 days old. The repo is found, right? So it looks good. Home page is also found. It looks like it's reachable. No CVEs were found, which is good. And it downloaded the package, and it carried out API analysis, but it failed. Well, we can try with some other package, and this will be fixed. But it did say that one risk found. So the home page is non-existent, looks like. And we can check that later. Let me, what's that?
Pip audit.
Pip audit.
Yeah.
All right. Single word?
Pip dash audit.
Okay. Correct?
One page.
Yep. All right.
Yeah.
Cool. So the author is Trail of Bits, 32 days old, which is good. README, sufficient README. Repo was found. Homepage also points to the same repo. No CVs were found. And 3 risks. So it generates new code at runtime. Perhaps it's supposed to, but you can check that by going to these. So the no line number was provided for this. Yeah, this will be fixed in new versions. But it also reads directories and files, and you can go to these files at these line number and then test. And you can see a lot of this is in test suite, maybe. So that can be ignored. But it's good to know what the package is doing. All right. So the source code of Packj is hosted on GitHub under Oscillate Inc. And as you can see, it's a standalone command line tool to vet open source software packages for risky attributes that make them vulnerable to supply chain attacks. And like you saw, it just takes 2 arguments, name of the registry or package manager and the name of the package. And we have already seen the output. But this only supports Python 2.7 and only tested on Linux. So it will download package metadata from registry using these APIs, and also download the package itself, the tarball from registry using APIs, and it performs API analysis using static code analysis. It checks for vulnerabilities using OSSIE database. And how do you customize this? So suppose you, okay, so we flag inactive or unmaintained packages that no longer receive security fixes, but if that's not a problem for you, what you can do is you can go to this file threats.csv, threats.csv here, and you can see that we categorize these attributes in 4 classes: malicious, suspicious, which is potentially malicious, vulnerable to code exploit, includes CVEs, and a lot of undesirable attributes. So if you don't want some alert because of some attribute, you can comment that out. For example, undesirable, the old package would be undesirable, and if that's desirable to you, you can comment this out, and then it will not provide alert. All right. Let's continue. So with this tool, you can vet individual packages by yourself, but we actually are building a large-scale vetting infrastructure for detecting supply chain attacks on open source package managers. And the service that we have created is package.dev. It's a software service, and it offers better accuracy because we have large data set. The package command line tool will operate only on one package. We can download millions of packages and then test them for any supply chain attacks. So it provides more accuracy. So a lot of free reports are available on pre-vetted package on the website. There's also a command line. There's also a CI/CD plugin to audit pull requests. That's also free. You'll have to create an account for that. And you can review security reports. You can endorse and share reports as well. Let me show that to you quickly. Yeah, so this is where it's hosted. If you go to view on GitHub, it will point to package. There's a CI/CD plugin that you can use and audit pull requests. You can upload your requirements.txt. You can search for packages. and there's a CI/CD. All right, let's see some of the reports. So this is a popular Python package, 2.6 million weekly downloads. As you can see, we provide some stats on this. So we provide code-related stats. What's the size, number of files, permissions? These are important. So the package would read files and spawn processes. These are only the two are shown here. But if you go to code behavior, you'll see a lot of details. So it'll read files, it'll spawn processes, it'll write to files. It generates code dynamically. And as you can see, this is being done at installation time, which is risky. So you can go to setup.py and this, and you can see that it's reading file. Well, it's reading README, so this is okay. All right. What is so? What else is? So it has package anatomy. It'll mention number of files that this package has, and provide some popularity graph. And you can see, okay, this feature is coming soon, but you can see this is used by 530 packages, which is good. And this last release was, more than 12 months. So, you may want to check that. All right. Let's look at BS4. This is a typo guard package. This is installed by the developer of Beautiful Soup, so that you don't accidentally install a malicious package. So if you go to PyPi, you can see that this is a dummy package, and it's just a placeholder. And if you look at the code behavior, it uses Beautiful Soup, which is the correct package as the dependency. So if you download BS4 by mistake because of inexperience, or you thought that was the correct name, you would get Beautiful Soup for package as dependency, so you're good. But this is how an attacker can publish a name, a package with a name similar to a popular package name, and you would end up downloading. So if you look at the number of downloads, this has huge number of downloads for a dummy package. And how do we know that this is a dummy package? It's just 2 KB, and there are only 3 files. It's only one function, right, and one dependency. So these stats are useful. PyTorch is another one. This is also a dummy or a placeholder package. You try to install PyTorch. All right, and you know that this is a dummy package because just 840 bytes, 3 files, 7 functions. All right, looks like it provides some good stats. Let's continue. So we did find over 35 malicious packages in January, and we reported that to PyPi. This is so these are some of the examples that we found. Let's look at them. So if you go to package, tool, and malware, you'll see these malicious package, example malicious packages that we reported, and I think some of them have been taken down now. So let's inspect this particular package, Chris Kian. So this was uploaded in 2021 September, and our static analysis module flagged this as suspicious because it's trying to spawn processes, it's trying to download data from network and read file, and all at installation time, which is pretty risky. So we looked into this, and we found that this package is indeed malicious. I think if you scroll down, you'll see what this package does. This package will do different things for different operating systems. On Windows, I think it's trying to override explorer.exe. On Linux, does the same thing. It doesn't override explorer.exe because there's no, but it will download the payload from this URL, and it'll execute this payload using subprocess. So we detected this. All right, saw some of the findings, and this was it. Thank you so much for attending the talk. The source code of the package is hosted on GitHub, and we have millions of pre-vetted packages reports available for free at packj.dev. And this is powered by OSSIE. Thank you.